Yeah, so welcome guys. So what if I told you we can use a simple maths to predict cricket scores? Sounds crazy, right? But that's exactly what a linear regression does. So let me explain this to you in the simplest way possible with cricket. So our today's topic is linear regression. Linear regression, linear regression, linear regression, linear regression. So what is linear regression? It's just a fancy word for drawing a straight line through the data. It's simple. So, but what kind of data? So, what I just told you, I just said, so drawing a straight line through the data. Data. All of this is the data. I mean, data points anyway. X axis, y axis. Right. So, but what kind of data? So in cricket, imagine we track how many balls Virat Kohli faces and how many runs he scores. So every inning is like a dot on the graph. So the balls. So these are balls and the runs on the y-axis. These are the runs. So linear regression simply says, let's draw one straight line that goes as close as possible to all these dots. So let me show you how close these dots are actually to the line. Here, 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 here. This one is far, this one is closer, this one is closer, this one is closer, this one is closer, this is far, this is far, this is far, this is close. Right, you got the gist of it, right? So and once we have this line, we can use it to predict the future runs. That's it. That's the whole idea of the linear regression. So using this line right here, we'll be predicting how many runs Virat might score. I hope you got the intuition of it. So let's go to the next part. Let me change the pen. Or should okay, but what exactly are we predicting? What exactly are we predicting? So we need to know what we are predicting, right? So in machine learning we have two things. One is feature and the other one is target. So what is feature? Feature is nothing but things we already have. We already have. And the target is what we are predicting. What we are predicting. So yeah, and this is target. So in our example, the one we just discussed, so balls are a feature or a target. What is it? You guys tell me, what is it? The balls faced are feature or a target? What is it? Since we already know how many balls a player has faced so far, that will be a feature, not a target. But we don't know how many runs he'll score in next 2 to 3 balls, so we have to predict how many runs he's gonna score. That's why runs are our target. Runs are our target. So simply feature will be on x-axis, which is balls, and target is y, which is runs. So features are like the input. This is our input and this is our output. These are the two things. So features are like the input and the target is the output we want to guess. Simple, right? But what does this word linear mean? I've been using that. So what does this linear mean? Linear. What are you? Who are you? So the word might sound, bit mathematical or complicated, but it's very, very simple. So it's just that means as the input increases, input increases, output also increases, but if input decreases, output also decreases. Simple. So this is what a linear relationship is. Linear relationship. The ones. Linear. Yeah. This is what a linear relationship is. Let me break this down. With an example. So let's say 5 balls have faced and 10 runs have scored, and 10 balls have faced and 20 runs have scored. This is y by the way, x, also a target, also the input. And let's say I've faced 15 balls and I've scored like 30 runs, maybe I'm that good, I don't know. So see the number of balls are increasing here, and number of runs scored is also increasing linearly. See that? That's a linear relationship. So mathematically, we can write this as y equal to mx plus c. So here y is runs, x is the balls faced, and c is just a starting point. We all start, a score with 0, right? No matter who you are, whether you're a Virat Kohli or a Rohit Sharma or Chris Gayle, whoever you are, doesn't matter. You all start with 0. Simple starting point. And our mysterious hero M. So M is a slope. What is slope? It is simply how many runs per ball I'm scoring. See? So in this example, balls are 5, runs are 10. So my M will be 10 by 5, which is 2. You can take some other example also and calculate. That will be giving you 2 only. So balls are 10 and runs are 20. Right? So M is 20 by 10, which will give you 2. So in other words, we can say that a batsman is scoring 2 runs per the ball in this example. So batsman is scoring 2 runs per ball. Did you get the idea? Let me show you this on the graph. So if I draw a graph, I'm bad at drawing, please bear with me. So x is balls and y is runs. So at 5 balls, 5, 10, 15. So I have 10, 20 and 30 runs. Let me choose some other color. And this is our intersection point. This is our intersection point C, and this is our intersection point if you draw a straight line, straight line like this. I mean, I'm really bad at trying, just, I'm just trying to give you an idea. So this goes like this. This goes like this. So these intersection points, I mean, I'm bad at drawing. These intersection points will stay exactly on the straight line. So this line, sorry, one sec. So this line is regressor line. So, but here's a twist. In real cricket, scores are not perfect, right? Scores were never perfect. Scores are not perfect. Not perfect. In real cricket. Are they? I don't think so. Do you? If you do, you better stop watching cricket. So let me give you the realistic scores right now. Right now, right at the moment. So let me give you the balls. I mean, this is a hypothetical example. Runs and the balls. So 55 balls, 12 runs. 10 balls, how many? 18. 15. 15 balls, how many? These are 18, so sorry, my bad. And if I score 15 runs, I mean, if I'm facing 15 balls, let me say, earlier I've taken 30, so I'll be taking 28 now. I mean, this is just an example. In 20 balls, I have scored like 42 runs maybe. So if I plot these points, they won't sit in a perfect straight line. Let me show you. So this is a graph. So 5, 10 and 15 and 20, and I'm just taking arbitrary points: 12, 18, 28, 42. So let me take intersection point 1, 2, 3, and the last one, non-veg, 4. Let me draw a straight line through this. Let me try drawing. I mean, the line is not perfect, right? The line is not perfect at all. We have a point here, we have a point here, we have a point here, we have a point here. So these points won't be sitting on the straight line. Some will be a bit higher, some will be a bit lower. I mean, I'm telling you to. Okay, let me make it more simple. So we have five balls and 12 runs. 5 balls and 12 runs. So 12 runs will be somewhere here, right? Somewhere here. And 10 runs will be, 18 runs will be somewhere here. And 28 runs will be, this is 30, so somewhere here. So so if I try to draw the straight line through these points, I'll have something like this. I can draw n points, right? I'll go like this, like this. See, are you getting the gist of it? So a line can pass through 3 points or n number of points in infinite number of possible ways. But that's not what we wanted. We want a straight line, a straight damn line that passes or characterizes, spelling I don't know man, characterizes all of our data points, all of our data points, all of our data points. But there are infinite possibilities. So 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 I have to, what should I do? So how do I choose it? How do I choose it? So that's where the concept called errors comes in. So to choose best point, best point possible line, sorry, best possible line, how do I choose it? How? How? See, it's simple. So I'll draw a line. I'll draw a line and check the distance between my points to the line. So these are my points, these are my points, these are my points, and this is my line. So I'll be finding the distance between these 2 points. I mean these points. So it will be like this. So it will be like this. So my line is like this, and my data points are like this. And I have to choose, I mean I may have different lines, so I'll be just measuring the errors. Error is nothing. I'll tell you what the error is. So in our very first example, what did we do? So our line told us that for 10 balls, Kohli has scored 20 runs. But in actuality, at 20 balls, he has scored. Oh, wait. No. See. So suppose our line predicts 20 runs in 10 balls. 20 runs in 10 balls. But actual is 18. So our prediction is 20. Actual is 18. What's the difference? 20 minus 18, 2. You got it, right? So at 20 balls, so prediction is 40 and actual is 42. So what's the difference? 42 minus, sorry, is it, yeah, 4 it's 40, sorry. So 40 minus 42, which is minus 2. So the total error, how much is the total error? Minus 2 minus 2. It cancels out and gives us 0. But is this representing the actual reality? No, right? So how do I tackle this? I'll simply square my error. 2 square plus minus 2 square. Because of this, it comes out like 4 plus 4, which is 8. So this is known as mean squared error. Mean squared error.